All right, this is a Math Models Unit 9 Lesson 1 video. This is looking at using linear and exponential functions to model data, which we've done in the previous, we've already done this in a previous unit. I think we did it in Unit 4. So we're going to jump right in because we already know how to use this, and we're going to be using a graphing calculator to do most of the calculations. 1 through 4 are vocabulary. Even these graphs, you're just looking up at the top and just picking which graph matches, type of graph that is. But it then jumps into linear modeling. It says using the following data to find a linear model for population growth of Denton, Texas. So we're going to jump over to the linear regression graph that we learned previously. I'm going to reload this. And we're going to enter the data. And then it says this weird thing: to find the values to put in list 1, subtract 1880. In other words, 1880 is going to be your 0. It's going to be your starting number. So we're actually going to put 0 as 1880. So let me go ahead and do that. We'll put 0. This will load. A little bit of issue here. Okay, 0. And then we'll put the first value, the value for 1880 here, 1,194. See if it'll let me copy and paste. It'd be nice if it did. It does. Oh, got to get rid of the comma. 1,194. Then 1890 would be 10 years later. And then 2,558. Then we have for me 20 years later, which is 1900. So we're going to do 20 for the x. And then for our y value, it's 4,187. Then we have 1920. So it jumps 20 years. So we're going to put 40 there. And we're going to do 7,626. Keep going here. 1930 is 10 years later. So it's going to be 50. And then we have 9,587. And then lastly, 1940, which is going to be 60. And then 1,000 or 11,192. 11,192. All right. So you can see it gets a little weird because of the values. But we zoom way out. Because the values are in the thousands, it's way up here on the graph. So I'm going to zoom out to get it to be where we want it to be. But it doesn't really matter, to be honest, because the points are spread pretty steeply on this graph. But what matters really is these numbers right here. If you remember previously, we have our M and our B. And so if I jump over here, it asks me about the A and the B. And A is going to correspond with M because on the calculators it uses A instead of M. But we know M is the slope. So the A or the M on our graph is 169. There you go, 0.61. So it's going to be B. And the B value, it's very confusing. The y-intercept is A, 969.01. That's right here. So then the equation would be those combined. So it'd be 169.61x plus 969.01. So that's going to be answer choice D. So that's pretty much the way that works. So then it asks us to use the linear model to predict the population of Denton in 2010. Okay, so 2010 would be, well, let's see, 230 years. So that would be the value. So what we're going to do is we're going to jump over here and we're going to create a new line and we're just going to say x equals 230. And then we're just going to zoom out until we see where those intersect. Let's see if we can find it. It's taking a little bit of time to load. Sorry about that. Okay, this is a little bit weird, but hopefully we can find where they intersect. Oh my gosh. Okay, maybe not. Let's see if we can zoom in here. Okay, it's switched at some point. Getting closer. Getting closer. Maybe they intercepted. Oh, there it is. The 39,979. Okay, that doesn't work. That's odd. So I guess they want us to actually plug that number in. So, and I think actually the problem is I used the wrong number. Sorry about that. All right, I make mistakes too. 130, that's a little bit easier to find, maybe. So I'm going to just zoom out here, jump down here until I find where they intersect. There it is right there. There we go, 23,018. And there it is. So the other way you could have done that is to type that number, 130, in for x, and so just solve it using the basic calculator. But you can do it on the graph as well. So now the next thing you're going to do the same thing, but with an exponential graph. So I'm going to just jump over there so you can see what it looks like. And I'll put a link directly to the exponential graph so you can see it. But it's the same idea. You're going to enter the data in this table, and then you're looking for the A and the B value. And actually this does it exactly the same way. So the A and the B value are right here, and they'll be listed down here under the bottom under parameters. So I'm not going to do anything else for that one because we've done it in the past. So you're going to enter the data. You're going to find these values, find the correct equation, and then you're going to do the same thing we did before, which is predict 2010 based on the data that you found. So just make sure you're using the exponential graph on that one. I think you'll be fine. We've done it previously. So then it just has some basic questions about the way you look at data. You can just answer those based on the lesson above. Then it has a few other questions right here. It says in the equation y equals 2,507 times 1 plus 0.12 to the x. What is the initial amount? And the initial amount is always this number right here in front of the parentheses. So the initial amount is this number, 2,507. And then it asks, what's the growth rate? And again, the growth rate is this value. So again, in any exponential function, the number outside the parentheses is the initial amount, and the number inside the parentheses that's being raised to x is the growth rate. Okay. And that's the same thing. The growth factor, same idea. Growth factor, growth rate, same deal. All right, so that's it for this video. And I'll close.